yeah, I thought it would be good to start off with some challenges of field work in tropical areas. For me, I was born and raised in Brazil. I've done field work in Brazil for my whole professional life. So when someone says challenges of field work in tropical areas, it's pretty clear in my mind what it is. But I thought it would be nice to do some illustration to show people who are not familiar with field work in tropical areas and show what the challenges are. So what I decided to do was basically do what every researcher does. I went to Google and I Googled challenges of field work in tropical areas. And apparently challenges of field work in oral literature is more of a challenge than doing field work in Brazil. I wasn't really happy about it, but anyway, I wanted some illustrations. And this is what I came up with. I was very disappointed because he's just showing happy people doing happy jobs. There's nothing of a challenge in here. You can see like a guy there with his snake and still he's pretty happy. And my favorite one, these two blokes here, they seemed like to have experienced a very wet day and they're still very happy about it. So yeah, I decided to embarrass myself in front of strangers and just show some real challenges of field work that I've been through in Brazil. So here I am, challenges of fieldwork. Challenges of fieldwork in Brazil by Bela Barata. So in tropical areas, there's extreme situations. So that's lots of something, and there's completely lack of other things. There's lots of rain, lots of mosquitoes, lots of mud everywhere, but there's also lack of mobile connection. There's no reception anywhere. There's no roads linking you to places, so it's really hard to get to places. When there are roads, there is no crossing, so you can't cross the road. And then there's attempts to crossing, which is usually translated into failure of crossing a river, drowning a boat, crossing the road because there's a tree over there, so you didn't predict that. And there's failure, even when you get to the place you wanted, there's failure to find your study sites. So there's some failures to find, where are my points? It's supposed to be here, but now it's all flooded. And also when you get to the field site, you get to the point that you have to do the sample, you fail to find your study species. So you fail to find the frog, you fail to find the lizard. So in overview, it's a general fail to do field work in tropical areas. But it's challenging, and there are ways of overcoming these challenges. So in this talk, I highlighted two biggest challenges that I have in my research. So the first one of them is mountains. So I'm working in a mountain area in Brazil, and the challenge is, the first one is actually you have to be very fit, because sometimes you have to go to the top of the mountains, it takes the whole day just to climb to the top, hike to the top, and then you have to camp there and stay there for a few days. But I highlighted three of the challenges of mountains. The first one, you need to watch your step, obviously, because you're doing a trail, you're marking your track on the GPS, and you might just hit a cliff. So you need to be really cautious if you're really hitting a cliff, not to fall down that cliff overnight, because you're doing surveys at night. If you need to climb the mountain, there's also risks of falling rocks, so that's also dangerous. And when it's wet, when it's most of the time, because it's a tropical area, there is lots of problems with injuries. You can get lots of injuries because it gets slippery. The other problem is snake bites. Well, the snake itself is not a problem. I'm a herpetologist. I see a snake, the first thing I want to do is grab it and take pictures and handle it. But you have to be cautious if you're working with people who doesn't have that much experience. And the problem is not the snake itself, as I said. Most of the problem is because you're far away from hospitals. So you're far away from any facilities that could actually help you in case of accidents. So you walk up the hill, if you're bitten by a snake, what happens is you have to track down 8 hours, sometimes tracking down, and then you hit the road. And when you hit the road, it's just a dusty road ahead, and you can't make any further progress because cars will not reach that site. And the third one, and probably my favorite risk works in mountains, is thunderstorms. You have lots and lots of thunderstorms when you're up the mountain. And you are very likely to be hit by a lightning. And that's one thing I had to include it in my risk assessment. I know the risk is very low, but still you have to predict that. And what they recommend you to do, which is over here, stop all activities, seek shelter in a substantial building, and hard top of a vehicle. which is not my case. I'm in the top of the mountain in Brazil. There's no access, there's no road, so that's not going to happen. The second challenge is working with rare species. When you have working with amphibians compared to other vertebrates, it's quite easy because you can get lots of data in just one occasion. So sometimes you go to a pond and you can easily count several species of frogs, and even like in a high number if they're highly abundant. But when you're working with rare species, what happens is you have very little information. And when you have information, even if you put them together, it's really hard to make robust assumptions when you fit the statistical models you're working with. So it's really hard to make conclusions about rare species because you don't have enough information, and it's really hard to get all that information. So I'm a very lucky person, and my research just puts challenge 1 and 2 together. So I work with mountains and I work with rare species. So my research investigates the ecological drivers of population dynamics and distribution, revealing patterns of amphibian declines and threats in tropical mountains. And I'm going to introduce you to my study site, which is the Espinhaço Mountains. As Bob said, I've been working there since 2009, so I've been working with frogs in this area for almost 10 years now. And it's a very special place in Brazil, and it's mostly unknown. So this area is considered the geographical divide of 2 hotspots biome. So you have the Atlantic forest on the east, here on your right, and you have the Cerrado here on the west. So the Cerrado is a savanna-like habitat, ecosystem. It's open grasslands, it's a very dry environment, so you don't get really high trees, so it's a very open, vast space. In the Atlantic forest, you have a proper forest. It's really close, you have high levels of humidity, and the Espinhaço Mountains divides those 2 biomes for about 1,200 kilometers from north to south Brazil, and it receives some humidity from the east, from the Atlantic forest, but also receives influence from the Cerrado to the west with open grassland spaces. So this view, I'm not sure the lights are helping, but this is a view from the west side, so if you from the east side. So if you, at the top of the mountain, you look east, what you can see is a vast green space, lots of forest, it's a flat area compared to the mountaintop, and you have lots of humidity coming from this area. This is all what is remaining of Atlantic forest from the east. And then if you look to the west, you can see these open spaces, open grasslands, typical from the Cerrado. And what happens in the mountain range is that this vegetation is growing on rocky outcrops, so you have a very rich soil. When there is soil, it's very rich, so all sorts of vegetation can grow there, but it's all growing on this exposed rock in the mountain range. Because of that combination of humidity and open spaces in a rocky environment, that area is particularly good for endemism of plants and vertebrates, and you have high levels of endemic species. In this case, I'm showing here, it's a very typical flowers that grow only on this area, on the Espinhaço range. And because of that high levels of endemism and high levels of threat for vegetation, it's considered one of the 200 global ecoregions of the world, a biodiversity hotspot for conservation priorities, and also a key biodiversity area. It's also an important bird area. And for the flora of the Espinhaço range, it's severely threatened by climate change, and in the next few hundred years, it's estimated to decrease and reduce the space to just to the south portion of the range. In case of amphibians, what you can find there, it's a very mixed kind of composition of frogs. So you have frogs that are typically from the Atlantic forest. They can only happen endemic to the Atlantic forest. And you have lots of endemic species exclusively representative from the Cerrado. But what you have at the mountaintop is a high number of endemic species. So 30% of the species of amphibians there, they're endemic to the range. And sometimes they can only be found in a single location, in a single mountaintop. For amphibians, the area is considered a center of endemic species. It's also been shown that amphibians, data deficient species and threatened amphibian species in the mountain range lack protection from the current protected area network, so most of them are insufficiently protected. And there's also a difference in unsurveyed areas. So some areas extremely surveyed, those areas that are close to big centers, they're close to universities, they are highly surveyed. But some of the areas, they lack basic information on species richness. And when they do have information, the current survey effort is not enough to actually describe the whole species richness of the area. Because of all that, this Piazza Range is considered a UNESCO Biosphere Reserve and is also in regional and national level considered as a conservation priority site. And in this area, lots of inventories is still necessary, especially on mountaintops where there's a big data gap for species and conservation. So that's how I ended up here at the També Summit. I was working in that conservation NGO, and the government was paying us to do a work to inventory protected areas and inside and outside protected areas that haven't been inventoried so far. So areas that lacked information. And this is a view actually from our house in Brazil. So I was looking to the Itambé every day when you have breakfast. That's the view you had. And I said, I'm going to go there and I'm going to survey that area because I know it's a protected area. It's the highest point of the Piazza Range. It reaches 2,062 meters. So I'm going to go there. I'm going to search frogs, and it's going to be awesome because no one has been there before. There is one problem in mountaintops. There's no fresh water. And if you're working with amphibians, you need fresh water to have frogs. So you need a lake, you need a pond, you need a river, and there's no such thing as the mountaintops. But I've been there before, so I knew that mountaintop would have potential to shelter water after a heavy rain. So I said, I'm going to wait for a heavy rain. I'm going to go there, I'm going to count frogs. And I'm going to use these bromeliads where you can find lots of those bromeliads in the mountaintop. I'm going to use these bromeliads as a water reservoir. They collect water during rainy seasons, and they can keep water there. So I'm going to look into those, and I'm going to look into temporary ponds. And what happened next was surprising even for me. We discovered new species of frog. So we discovered new species of frog inside those bromeliads where no one was looking them before. And that was a very exciting outcome of that work. So it took us a few years actually to describe the species and get it published because these frogs are tiny, they're very small, and the bromelia is like a maze. So you try to collect them in one side of the bromelia, they just jump to the other side, and it's really hard to collect good sample size to actually make the description. Not only that, we had problems because we described a new species of frog, but it was actually a rare species of frogs. So all the genus represented by these little frogs living in bromeliads, there are 4 species of those genus. And they're very, very special frogs for particular reasons, which I'm going to highlight now. So these frogs, they are restricted to bromeliads. They complete their whole life cycle inside the plant. There are 99 species of bromeligenous frogs. They're all restricted to neotropics, and they're all restricted to bromeliads. Being bromeligenous means that you are developing your whole life cycle inside that plant. So tadpoles, juveniles, and adults are restricted to the plant, and we don't know anything about dispersion of those species of frogs. So this is a cross-section of bromelia, in case you've never seen a bromeliad before. So probably the most famous bromelia is the pineapple. So that's the bromelia cross-section of the bromelia. And you can see here why this plant is special. It has a neck texture that just helps to retain water even during the dry season, and that offers a microhabitat to several species, not only your frogs. And in Brazil, bromeliads can be quite big. So they're not like tiny bromeliads that you see in Tesco. They're really big bromeliads, and they're called tank bromeliads. So they can retain a large volume of water. So 70% of bromeligenous frogs are either data deficient or threatened with extinction. 55% have very restricted ranges. Some of them, most of them, are only known for a single population in a mountaintop. And less than 20% of the literature focus on ecologies. Whenever you come across a paper on bromeligenous frog, it's either a taxonomic description or a distributional range study. So there's few studies on ecology. So no, I'm going to drop what I'm doing now. I'm going to do a PhD. I'm going to do lots of ecology of those frogs because they're very interesting. There's nothing being done. So I said I'm going to mark those bromeliads. I'm going to put a tag there, a number tag, and I'm going to visit them several years. I'm going to see what's happening in that population. And that's what I did. So each one of those dots is actually a bromeliad that I marked. And I did repeated visits to those bromeliads during 4 years, 4 months each year, 15 to 10 days of survey after between surveys. And just to make sure we are like in the same page, both bromeliad and frog are restricted to one mountaintop in Brazil, above 1,800 meters, in an area estimated to be less than 0.5 square kilometers. This is where the car can get you. So if you have a big team, the car will get you to that point. After that, you have to use a donkey. And that's probably the most exotic piece of equipment I've ever had in my whole life, a donkey. The donkey is amazing. His name is Thunder, but he can only get us to that place. He can't go any further. He actually could go further, but the problem is that's the last point of fresh water. So in that area, we have to camp. Then we stay there for several days, and what we have to do next is just hiking 8 kilometers up and down the mountain to count the frogs on those bromeliads that I tagged. It sounds easy, just go there, hike here, camp there, and do your counts. But in reality, what happened is Thunder, he's not really happy with me. He doesn't like to work very well with me. We don't work really well together. So what happened is every time we have to carry our own stuff. So we have to carry our own equipment when Thunder is not working with us. And because of that, we have to be very precise to what you actually bring into the top of the mountain. So you have to be extra careful for the amount of equipment, batteries, things like that. You have to think prior, what are you going to bring to the top of the mountain? And that includes food. So we have to count even food because of the hiking trail. Cooking facilities are not the best. I mean, we do whatever we can. That's our tea time in Brazil. That's how we cook, how we make a tea over there. And also showering facilities are not the best. We don't have any infrastructure in that area. On top of that, I showed those amazing views, but that's very unlikely to happen if you go to those mountains, because usually what you get is this landscape here. So it's usually covered with a thick fog and a mist, so it's really actually dangerous to fall on the cliff. When I say fall on the cliff, it's because you can't see where is the next step. And we're always surrounded by thunderstorms, so we can see thunderstorms everywhere. There's lots of risks of injuries, and that happens almost every survey. And on top of that, we have to work at night. So it's really hard to convince people, hey, come and work with me, count frogs in the top of the bromeliad. It's going to be amazing. We're going to count your food, and you have to walk 8 kilometers and work at night. So it's really hard to convince people to come and work with me. So the first thing of my PhD I needed to sort out the survey effort and sampling design. How many times do I have to go to that mountaintop to actually see a frog? And how many times these different group of people, how many times do they actually have to go to detect the frog inside the bromeliad? It's really easy to detect. But this is what you usually get. You get like a leg, a head, something really, really good that doesn't look like a frog. So what we found is that actually detection changed with the observer experience. So what you have here is that experts, I'm considering myself the expert. Experts, they have 65% chance to go to a bromelia and detect the frog. And people who receive training, they also have different detection probabilities, and the error, they increase when you have less of training. And from this detection probability, you can actually do simulations and calculate how many times do you actually have to go to the top of the mountain. And we came up with this magic number saying, okay, 4 visits is necessary to detect a decline of 30% in that population. And I thought, okay, 4 nights, it's okay to go and do all that repeatedly every month. So we came up with a sampling design of 143 bromeliads visited for 4 nights over consecutive years. And then I wanted to look at natural history, ecology, population dynamics, everything I could about these frogs. First thing we did, okay, they're occupying the bromeliad, but what's going on inside? So here we installed some camera traps in the bromeliads to see how the frogs will move. And here you see like a rare encounter of 2 frogs using the same bromeliad. This sequence here, it's a very rare occasion, so we came up with the number of 80%. 80% of the time frogs are inactive. They're not moving at all. So you have a really reduced, a frog with a really reduced mobility, probably with really reduced dispersal capabilities. And from there, you can calculate activity pattern, and we see a peak activity peak here between 7 and 10, and after midnight, which is exactly the time we're doing our surveys during the night. Then when it comes to ecology and population dynamics, I was very interested to understand the predictors of abundance of those frogs. And this graph is showing preference of bromeliads, use of bromeliads, and indicating some preference of bromeliads of different characteristics. And in summary, what it's actually showing is that you are more likely to find more frogs when the bromeliads are large in size, probably because they retain more water for frog development. You can find more frogs when there's less invertebrates using those bromeliads, and you can find more frogs when bromeliads are grouped together, forming this big, conspicuous patch of bromeliads. That same characteristic, bromeliad density and volume of the central tank, also affects predicted probability of colonization. So you increase colonization if bromeliads are larger and if they occur in a higher density. And because that was something affecting the dynamics of that frog, I wanted to test if fire would have a negative effect in that population. In 2016, in the middle of my PhD, the study area got on fire. The first thing I thought, frogs will disappear, frogs extinct. I don't want to be the first person reporting real-time extinction. I don't want to be known for that. So I was saying, they survived the fire, and I was interested to see if frog would affect the colonization rates. And what we actually found is that frogs are less likely to colonize. They decreased by half the chance of colonizing a new bromeliad if that bromeliad was affected by fire. Elevation was predicted that was appearing in all of my analysis. So I was interested in total counts of frogs, and elevation interaction with size was positive for the bromeliad. Probability of occupancy increased with increasing elevation, and the mean number, the predicted abundance of individuals at each size also increased based on elevation gradients. So elevation was playing an important role in that population. And also, this is the method distribution of the dynamics, population dynamics for those frogs. And here on your left, these are the high elevation sites. And what you can see here, the probability of colonization is higher on those sites in the mountaintop. So it means that on the mountaintop, bromeliads are more likely to be colonized and are less likely to be extinct. So if movement is happening, it's probably happening in those sites over here. So, okay, I knew what was going on with the predictors of abundance. I knew what was influencing occupancy, all my parameters, and I wanted to look in population trends. And I came to this. So these are all my sites, my years that I surveyed. And I noticed that there was no trend. So the population is stable. There was a fire and they're still okay, so there's no significant change in here. They're all stable. But I knew that elevation was playing an important role, and I knew that 60% of bromeliads were occupying the mountaintop, and here, down here, just 9% of bromeliads were occupied. So what I did, I break it down, this population trend, into elevation categories, and we saw that in the lowlands, there was a decrease in the population. In mid-elevation, there was also a decrease in population. And in the mountaintop, what we found is that the population was increasing. And although that was not significant, it was probably indicating that the population is moving upwards to the top of the mountain. And this is probably related with, again, with the structure of the plants. So at the mountaintop, you have higher density, and you also have a higher, bromeliads are larger in the mountaintop. And the final thing I wanted to look at was species distribution and patterns of rarity. So I wanted to search for new population, because if something happened with this population, it's done. They're the only population now. If that goes wrong, they're extinct. But where do you go? If you look around, there are mountains everywhere. They're all open habitats. They all have bromeliads. So where are the places that I can actually go and find high probability of finding frogs? And I came across this paper published in Nature in 2003, and they model few known points to find new populations of reptiles in Madagascar. So I thought, I'm going to do the same. I'm going to publish in Nature. I'm going to be famous and everything. It will be nice. But I had a problem. I had 1 point of occurrence for those frogs. So the population was only known in 1 point. And you can't model anything if you have 1 point. Again, the problem of rare species. So I thought, okay, these frogs are restricted to plants. I can get lots of information on the plants. So I'm going to find and model bromeliads instead of the frogs. I'm going to use the bromeliads as surrogates to find a new population. So I visit many areas. I got 21 points I could use for bromeliads, and we did this distribution model that show high probability of finding frogs in areas that are in red. And again, elevation played an important role in that distribution, and also high levels of rainfall and a stable temperature across the years. So I visit many areas, and when we got the distribution map with the high probability of occurrence, I chose 4 areas to be visited. All of those areas we could find bromeliads in the area, so it was really good to detect, to model the bromelia. And we visit areas inside and outside protected areas. And we could find bromeliads in all areas, but we only found frog in those sites. So this is a red star show the original population of the frog, and we were able to find a new population over there further north. So this is the area where the new population work. It's also a protected area, so habitat is quite unique over there. And bromeliads in that area, they occur on the trees, on the ground, so there were frogs everywhere. I got there and the frogs were calling. I was working for 4 years in the other area, and I have heard the frog calling for 8 times. And we went there, and that day was really, really humid, and frogs were calling like crazy. And this is the little fellow we found inside the plants, inside the bromeliads, and I was overexcited. I said, oh my God, if the model works, you can actually model the bromelia, use it as surrogate to find frogs. That is amazing. I couldn't sleep that night, but not only because the model worked, but because I was really suspicious, because I've heard the other frog calling. I've heard this frog calling, and they actually don't match really well, so maybe I wasn't hearing well the other one. So I was very suspicious. I took them to the lab, and I compared them. So on your right here, you have the population that I was working with, and you can see his hands is quite different from the new population that we found. And what happened next is, maybe it wasn't a surprise, we discovered a new species. And it's a rare species, again, so we did it 2 times. So yeah, this is all based in the models, so it really works for these bromeligenous frogs. Good news, find a new species, but bad news is it's only known, what species I was actually working with, it's only known for 1 population. So it's a single population, and if you cut down the area to just the mountaintop, where the population is actually occurring above 1,700 meters, that area is of 2.39 square kilometers. And if you narrow it down to 1,800 meters, where population is stable and population dynamics are working, that narrows down to 1.85 square kilometers. So you use all those data to feed into the IUCN species assessment, and it's now classified as critically endangered. So what is the take-home message from this data that I've used, that I've come across my PhD? So frogs are active at night. Camera traps can work for those types of frogs because they're self-contained, so it's easy to get information from them. Detectability changed from what we've seen, so you have to consider that when you're actually going there and trying to survey frogs. We also found that the structure of bromeliad is more important than the local weather conditions. So in all the models we did, the structure of the plant was more important than local variation in climate. Elevation plays an important role, not only for species ecology and population dynamic, but also in the distribution model. So elevation is an important thing to look at if you're working with bromeliaginous frogs. Fire had a negative impact in the population, and unfortunately the population is declining, and we have to better manage that area so fire will not happen again. And finally, there's lots of opportunities there. There's lots of gap in information. And if you use the bromeliad for this frog, you can actually not only find new population, but also find new species. And I think overall, if you consider all these information here, as you can see, the frog itself is rare, it's hard to get information, but if you work on a different perspective, and in this case you have to look to the bromeliad, not to the frog itself, it makes it easier to come to conclusions and get more data and make robust conclusions about it. So all this data is now feeding the National Action Plan that we work for the species. We're talking with the project manager, the park manager and the park rangers how to better conduct tourists in the area, and we hope to improve the protected area management plan to protect that species. Thank you.